Hello, today I'm going to speak to you about trigonometry. So we're going to learn about the trigonometric functions and how to use them and also their values. Now let's start with the most popular, which is sine. Sine of alpha, that's my angle, is the opposite over the hypotenuse. So this side divided by this side, if it's a right angle. So your triangle has to be 90 degrees here. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Cotangent is, you could say, if you flip this around, similar to tangent, it's adjacent over opposite. Now, if you picture a circle, I'll explain later on why I drew a circle and why we're going to derive this equation this way, but if you bear with me for a minute, this is the analytic description of a circle in analytical geometry. Around the point 0, our radius is 1, and this directly relates to the expression cosine squared of alpha plus sine squared of alpha equals 1. Why does this equal 1? Well, if you think about cosine, it's got its values all on the x-axis. You think about sine, all of its values are on the y-axis. So essentially you could say that sine is y squared and x is cosine squared. And that's how we get this very popular formula. Now, the graph of sine alpha looks something like this. So, if alpha is 0, then sine is 0. You can see that here quite clearly. And if sine is 1 at the point pi over 2, and I'll show you why. So if you think of basically how long your whole circle is, well, you know the expression is 2 pi times r. So basically, essentially, if r equals 1, then what you end up is 2 pi. So your whole circle's length is 2 pi. Now we can divide that number. So half the circle is going to be 2 pi divided by 2, which is pi, and half of that is going to be pi half. So that's why our sine of pi half is 1. And once we continue down, so we're going downwards on the y-axis to the point pi, we get 0. Now we continue some more, and we get minus 1 at the point, 3/2 of pi. And at the point 4/2 of pi, which is 2 pi, we get 0 again. Now, I'm going to quickly show you cosine of alpha as well. So the graph is a bit different because cosine of 0 is 1. So at the point 0, we have the value of 1. And at the point minus pi half, I'll explain what the minus sign stands for. We have the value 0. Then the function continues to pi half, then to pi. Its value is -1. And then it continues all over to 3/2 of pi, which is basically identical with minus pi half. So when we have our circle, we rotate in a specific direction. For plus values, we rotate in the anti-clockwise direction. For minus values, we rotate in the clockwise direction. So if I was to ask to describe pi half from the opposite direction, it would be minus pi half minus pi minus 3/2 of pi, and so on. You can go in both directions really. Now there's a funny thing with tangent, is that tangent of alpha can be also described as sine of alpha divided by cosine of alpha, and its graph is not really similar to the other two functions. So with tangent we sort of have a problem because, and cotangent as well. So this is 1 and -1. We just go all over the place. Then if we draw a straight line through this point, on this all of our tangent values lie, and the way we get our tangent values is basically we say, let's say this is pi over 4. So we sort of draw a line and get to this point. Then for our negative values below the y-axis, below 0 basically on the y-axis, let's say this is 3/4 of pi. Do we get negative values? So negatives we always get here, and positives we always get here. Now what happens when we just have a straight line pointing upwards? Well, we can never really assign a value to that, because if it's just a straight line going up, it never really hits this line. Same applies to cotangent, though it's a bit different. So with cotangent, we draw a line somewhere around here, 0.1. Our plus values are again in the same direction, our negative values same direction as well. And when we have a straight line, again here, then so around pi, we can't assign any value to cotangent. Let's just find out the tangent of pi over 4. Pi over 4. So think of pi as 180 degrees, because a whole circle is 360 degrees, which is 2 pi. So 1 pi is 180 degrees. So that's 180 degrees divided by 4. And I urge you to calculate that. So 180 divided by 4 is going to be, you don't actually need to calculate this at all, you could just obviously it's good to calculate it, because then you know the specific values of all of these functions. But what you do first is you put your sine value here, and then your cosine value here. So pi over 4 is 45 degrees. So sine of 45 degrees is square root of c over 2 divided by cosine of 45 degrees, square root of 2, and that is 1. You do not need to learn this table. There's a really clever trick I can teach you. So if you hold out all of your 5 fingers on your hand, and this is 0 degrees, this is 30 degrees, this is 45, this is 60, and this is 90 degrees. You can find out the corresponding pi values, so this is pi half, this is pi fourth, pi third, pi over 3, sorry. Then all you do is your sine values are on the right side and your cosine values are from the left side. So let's say I want to find out the value of sine and cosine at the point 45 degrees. So what I do is I put this finger down, and then I've got 2 fingers from this side and 2 fingers from that side. So what I do with the number on top, I have to always square it, so that's square root of 2, and then I put it over 2. And here, again, from my cosine, the square root of 2 over 2, because I've got 2 fingers, and I always divide all of my things by 2, all of my numbers on top. This is just really a trick. What about 60 degrees? So I have 3 fingers on the side for sine and 1 finger for the cosine side. So that'll be the square root of 1 over 2 for cosine, and for sine of 60 degrees we'll get the square root of 3 over 2. Square root of 1 is 1, so we get 1 over 2, and the square root of 3 over 2. Now let's just check if what I'm saying is correct. So 60 degrees. Sine, square root of 3 over 2. For cosine, 1/2. Let's have a look if that's true. And we arrive at the same value. So that's just really a sort of trick you can use instead of just memorizing this whole table. So that is all for today. I hope you enjoyed the video. Please make sure to like, share and subscribe, and see you next time.